Let us study collaborative filtering. So what is collaborative filtering? It is called filtering because it is basically an information filtering process based on past records. It is also called electronic word of mouth marketing. It can turn visitors into customers, acting as an e-salesman. And there are three key components in collaborative filtering. The users, for example, the customers, are those who provide the ratings. And the items, for example, products, are what to be rated for. And the ratings indicate the level of interest of the user for an item. So the ratings are the core data, right? So the data we have is basically a rating matrix like this, right? So the rating matrix is a matrix with the rows typically by users. For example, there are 3 users here, so there's 3 rows. And the items are the columns. So for example, 4 movies. And the rating a particular user gives to a particular item is the element of the rating matrix. And in a typical recommendation problem, most of the ratings are missing. And this is what we want to learn and what we want to predict. Those are the missing ratings. Right, so the objective of collaborative filtering is to predict how well a user will like an unrated item, and given the past ratings for a community of users. How does collaborative filtering work? The input to collaborative filtering will be the many users' ratings for many items. And it will build a model to describe similar users. Right? Those users have ratings that are strongly correlating to each other will be considered as similar users. And then based on this model, we can recommend items rated highly by similar users to a particular user. And here is a nice illustration on Wikipedia for a collaborative filtering approach. And so this is a rating matrix. And so, this is the end of the, so there are several items and several users. The users give ratings, and we want to know that this user's interest in your TV. Right? So this is a rating matrix. You learn the model and do the prediction. And so that is a prediction. So the prediction is that it will not like the TV. And in terms of ratings, the most important data, there are also 2 categories. The first category is called explicit ratings, right? So they are the direct indication of a user's interest on the items. And so they are the most accurate descriptions of users' preference, but they are challenging in collecting the data. And so for example, typically what we use are 5 scale ratings, right? So 5 stars ratings. There are also implicit ratings, which indirectly measure the level of interest by observing user behavior. They can be collected with little or no cost to the user, but the rating inference may be imprecise. implicit ratings including the actions that you actually search for an item, whether you click on certain items or certain links, or how much time you spent, and how much time, for example, you spent watching the video, and so on. So they are imprecise. For example, if you just opened a YouTube video, but you receive a call, right? So then the video just keep playing, the computer will think that you have been watching the video, right? So there's no way know. Maybe it's really a boring video, right? If you will rate it, right, you give a very low rating, right? But if it's based on implicit rating, it can be very imprecise, right? Because there are many reasons that certain behaviors has occurred. And in terms of the rating scales, the most popular one frequently seen is the scalar ratings, right? Numerical scales such as 5 stars, right? So that's most commonly seen ratings, 1, 2, 3, 4, 5 scales. And there are also binary ratings, right? So for example, agree or disagree, good or bad, like or dislike, right? So for example, in YouTube videos, there's 2 options, right? You can do a rating, whether you like it or whether you dislike it, right? So there are also unary ratings, right? So they are a little bit similar to the implicit rating, but they are unary because there's some clear explicit action, right? So for example, they are looking at the presence or absence of an event, right? For example, you purchased a product on Amazon, right? So you browsed a video and you searched some queries and your mouse movement, right? So it can all be kind of unary ratings. But you should be aware that no information about the opposite, it doesn't mean that for the opposite, the rating is very low, right? So it has no interest. It's not equivalent to no interest, right? So because there is the absence of an event, you didn't buy it, maybe because you're short of time, right? So maybe you need to go for a lecture and you have no time to buy it, right? So then therefore you close the window, right? So therefore it's no, it can also only confirm the positive, right? But not the negative. And there are certain preferences for a collaborative filtering system to work. They will, this kind of system will prefer many users, many items, and many ratings. And it assumes that the users will rate multiple items. And it also assumes that the users will have some other users with similar needs or tastes, right? So if someone has really a very unique needs and a very unique taste, so if the users in the database has no similar needs or tastes, right? So then collaborative filtering will not work. It also assumes that the item evaluation will require, right? So it will need personal taste, right? Some personalized characteristics to evaluate the item, for example, movies, music, right? So different people will give different ratings, depend on their personal taste. It also assumes that the taste will persist, right? So it means the taste will be stable, right? Stable, so that you can recommend the items, right? So based on the taste. So these are all the assumptions, right? So it may not be perfectly satisfied in real world, but these will be the cases that collaborative filtering will work the best. And in terms of the methods for collaborative filtering, there are 2 major approaches. The first one is memory-based approach. It will basically predict the ratings using past ratings directly, right? So it will use the ratings, the numbers directly by compute weighted ratings given by other similar users. And there are user-based approach for memory-based collaborative filtering and also item-based, right? So they are not machine learning based. They didn't learn anything, right? So they just compute the correlation and give a weighted rating. And we are not going to study further on memory-based approach, right? So this module will study model-based approach for collaborative filtering. In this approach, we will build models to model the users based on past ratings, and we will also model the items. And then we will predict the ratings using the learned model. And so that is model-based approach. We are going to build models for the prediction. And in terms of evaluation, we have 3 common measures. The first one is mean absolute error, right? So this is a PIJ is a prediction of user I on item J, and RIJ is a ground truth rating, right? So when we have the ground truth, we can withhold the ground truth and do the prediction, and then compute the error, take the absolute value, and take the average, right? So that's mean absolute error. And we can also further normalize this error by divided by the range. For example, some ratings may have a scale from 1 to 5, some maybe 1 to 10, some maybe 1 to 100, right? So therefore, if we normalize it, it will be more comparable. And a third measure is root mean square error. That is, take the difference and then square the difference and take the average and then take the square root. And there are several key challenges in collaborative filtering. One of the very significant challenge is called a cold start problem. That is the case for example, when we have a new user, right? So the new user have just registered and there's no information about the user. It didn't read any items, right? So therefore you have a cold start problem. So the solution is to ask the user, for example, to raise some initial items, right? Just give some incentives, or make some non-personalized recommendation, for example, popular items, or items under promotion, right? So for example, something have very significant discount, right? So you can, if you browse Amazon, right? So the homepage, you will see that kind of things. And you can also try to ask the users to describe the taste or using demographic information, such as user is in Sheffield. And when you have a new item, such as new movie or new product, right? So they will also face the cold start problem. And the solution is basically one is to randomly select the items, right? So that even new items will have a chance to be recommended to a user, right? So for example, in 10 items recommended, right, you will mix 1, right? So you put 1 of new items in the 10 of them, right? Usually that is the approach by the online companies. And you can also take a non-collaborative filtering approach to analyze the content, right? So and to do the recommendation. Another significant challenge is the sparsity of the user item matrix, right? So especially for online companies, you can imagine how many users are there in, for example, on Amazon, and how many items are there on Amazon, and how much percentage of those items will be rated by a particular customer, right? So usually a customer will buy dozens or hundreds of items, but there are millions of items. Therefore, the rating matrix, right, so will be extremely sparse, right? So that is, most of the entries are missing, right? So most of the entries are missing. So that is a sparsity problem. Another problem is scalability, right? So for e-commerce companies, right? So there are millions of users and items, right? So how to deal with this large number of users and items to make the system scalable, right? Also, you need to have a real-time recommendation. It can't take you 1 hour to compute the recommended items, right? It should be very fast. Otherwise, the customers will just leave, right? So if you don't do it very fast in real time. Therefore, there's also a scalability challenge, right? So that's a very high-level introduction to collaborative filtering. And in the next section, we will look at a particular model-based approach to collaborative filtering called matrix factorization.